Good morning,
Good
sir.
morning, sir.
Good morning,
Good morning, sir.
everybody. So, yes, let's start for this week topic in Python programming, which are called loops. Right. So before we move further and discuss about this very powerful construct called loops in programming, I mean loops like if-else statement, also like integral part of any programming language. So what we have done so far is like we have discussed data types, like we started when we started discussing programming. Then the essential element of the programming, any programming language for that matter, is like data types, the kind of data that you deal with in your programs. And then you use variables and expressions, like variables is stored, I mean, given the name for store the data, and expressions which we can form of different nature, like we can have arithmetic expressions or logical, which is also called as Boolean or conditional expressions. Right? And you can evaluate those expressions and have this assignment statement. So we have seen like this, one of the important kind of statement is assignment statement, right? Which has some x equal to or some variable equal to, and then this whole right hand side, where the right hand side is going to be first computed, evaluated, and will be the value will be stored. The resulting value is going to be stored in x. Right, so this is nothing but the assignment statement, where we have some left hand side, which is typically a variable followed by this equal to sign. This is the assignment statement, right? And then the right hand side. So we have seen this assignment statement, then we have seen conditional statement, right? Last week, which is if, simple if, or if else, or you can use like nest multiple ifs in one statement. So if, elif, 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 and whatever condition matches in this elif part, that will that block, that code block is going to get executed, and the rest of will be ignored. If nothing, none of if or elif part is matched, then there is a final else block, which is we can say default one. If nothing else, no condition matches in this if statement, then finally this else part will be getting executed. So this we have seen, which is like one of the kind of control flow statement, right? When I say control flow statements, then you know that I'm talking about the execution control. That is how instructions are or statements of a program is getting executed one by one. So you can see here, then when we use this if statement, it allows to transfer of control from this normal sequential execution to like this branching, which depending upon which condition is true, right? Then it will the execution will jump to that condition, or that code block followed by that condition which is true, right? Or which is false, right? So depending upon the condition, the outcome of the conditional expression that we use, right? Avdesh Kumar Gupta. Yes, so please make sure that your mic is muted. And there's another thing that very important thing that you should, all of you should be aware of, that when you log in through your whatever, like some login ID, so this must be institute login ID. Otherwise, we are not going to give you the attendance for that session, and we are going to remove you from this session. So make sure you are using institute login ID to log in to join this course, because this is how we record your attendance. So if you are using your personal Gmail ID, which is unknown to us, we are going to simply mark you absent. Right. So continuing with our the recap, that we have seen in this course so far, like last 4 weeks, we have discussed this data types, then the important part of variable expression, then this control flow statement, one kind of control flow statements, which is like conditional statement, if else or if elif, and then there can be multiple elif and then followed by the last else statement, right? Or the part of this if statement. Right? This is one single statement. This is like whether if it is simple if or if else or if and then multiple elif and then followed by this else. It's like one single if statement, conditional statement. Then now we are going to discuss these loops. So all these things together forms the basic building blocks of a programming language, and similarly for the Python. So once you are like familiar with all these things like data types, the variables, expressions, then conditional statements like if or loops, once you are familiar with all these elements, you can be confident of like writing small programs, even bigger programs also, like all in one single large file. So now you can, once you are familiar with loops, then you can be sure about that. Given a problem, I can write the code. Any problem, about that matter. I mean, even if it is a bigger problem, you can write that code in one single file, one by one. And if you are also like comfortable with functions, then you can divide this whole code into some functions, and those functions may be called in the main code as and when needed, or one function may call another function. So this is more of like code organization. But more or less, this function body is also going to use these very much basic elements, which is like data types, the variables, the expressions, the assignment statement, the conditional statements, and then the loop statement. So you will see that primarily your program will consist of, I mean, functions we are going to use to organize our code, to arrange this whole code in a nice like chunks of small code. And then we will aligning those functions in our code to call them and those kind of things, right? So it is more of like code organization when we use functions. But if you like figured out, if you want to figure out that what are the basic building blocks of the programming language, that I can tell you, like all those programming statements will be either going to be assignment statements or conditional statements or loop statements. Right. This is how your whole program is going to look like, right? Even if it is not using any single function, right? But this is what we are going to do more and more, that we are going to use functions as and when we can use them. I mean, we can define our own functions, or we can use the language defined functions, or we are going to use the third-party libraries or functions included in third-party libraries, which we were going to import in our program, right? There are also like these libraries also available with the Python, but we can also use the libraries, which is nothing but the libraries of functions, which you can reuse in your code, which is defined by, or which is shared by some other community or people or organization, right? So these libraries can also be used as, or the functions inside the library can also be used in your program. But the basic idea that we will be like now should be familiar with and now confident of, that these are the basic building blocks of a programming language. Three kind of statements: assignment, the conditionals, and then the loops. So if you are comfortable with these three kind of statements, you should be comfortable with, at least in principle, that you can write programs, right? And then when you start writing them, you are going to make use of these conditionals, these assignment statements, and the loop statements also. Like, so very soon in this lecture, we are going to discuss like these loops, the different kind of loop construct that is available in Python, and how we can use them to solve those problems, those scenarios where the loops can be useful, can be used to solve that part of the problem. So as I said, all the above Python construct are basic and essential elements for writing program, right? So you must be paying enough attention in to make sure that I mean this week and the previous week all together, this experience must allow you to be somewhat now comfortable in writing program. Obviously, we are writing small programs, so that's not a problem at this point of time, because soon we will start writing bigger program. But you will see that most of these program or all these programs are typically making use of these basic building blocks, basic constructs. And obviously, we are sharing some demo code every week, right? So that is one important resource that you have, and you can play around with that demo code. And another important resource that you have, and which everybody has, right? This is like internet resources. So wherever you are stuck or you are finding any difficulties, just write your queries or that particular part which you want to understand, a particular construct or particular example, and you will get enough example on internet to see that how a particular construct is written or used, or how we solve some problems in using some functions or those kind of things. So you are highly encouraged to make use of like internet that you should be using already. So let's get going about like loops. So let's say we have
Hello,
a problem like printing multiplication.
sir. Sorry to interrupt, sir.
Yes, please.
I had few discrepancies in the quiz answer, sir. Whom should I contact regarding that? Our TA or you?
So see, first thing is like you should not interact for your personal problems or any such problems which we can take in the afternoon sessions. Your TAs are there, and your first line of contact is TA.
Okay, sir.
So whenever you have any problem, that's what I mean. We have made the arrangement in this course. As soon as you are facing some problem, whatever like your comes to your mind, you should be asking your TAs to for an answer, for an help here. If the TAs are not good enough to provide you the help, then you can contact any of us. You can contact Dr. Vijay Paul Singh, or you can contact me also. That's not a problem.
Sure,
and
sir.
For that, it will be good if you drop a mail rather than, I mean, making.
I'll do it. I'll do it.
Sir, just one thing, please. Last 3 classes before you said no that one quiz can be exempted.
See again, I please don't disturb me. I mean, this is the last person I am interacting with. If you have all those questions, please wait till either at the end of this class or some other time, right? You cannot. Okay. I mean, how can you afford me to stop in this? Like, the 300 odd students are like attending this course, and they want to go through all this learning, which I am going to tell you, and you are asking me some silly questions. Why you are doing this? So that's not a good idea. Please refrain from this, interrupting me. For all your queries, as I already told you that we are going to answer that, we are going to address that. That's what the whole organization we have created for running this course. And you, for the first year students, we have made extra provisions also, like in form of TAs that to give you personal attention. So please have some patience, right? And go through. So let's start about like thinking that where the loops can be used, right? So loops, as I said, it's a very powerful construct, but then you need to figure out that where we can use loops and how we are going to use loops. So I will be giving you some scenarios, right? Where we may think of that there is some repetitive task, and why should we writing so many statements to solve this task rather than can I do it in some repetitive form, right? Iterative fashion, right? So that's a lot of repetition. So can we solve this problem in some different way? And that's what you are going to use loops. So for example, you want to print this multiplication table. So like 5, 5, 5, 2 are 10, and 5, 3 are 3 are 15, 5, 4 are 20, and so on and so forth. So this is very familiar problem that you've done in your early school, right? So you've written so many tables of like even bigger number, and you probably have to mark that up to make sure that you score good if you know those tables for hand numbers, right? So how do we write this program here, right? So a very simple idea that we can do is like, we take this number, we ask the user to provide that which table I need to display. Then, so you will get an input here, enter a number, and this number is stored in the N. And then what you're going to do, you're going to print all those, the element of that table. That the first element is like N. So N, and this is the cross 1. So this is what you're going to print, right? Exactly 5 cross 1 is 5 equal to 5, and 5 cross 2 equal to 10. This is what you want to print, right? And therefore this, since we want to print in that specific format, so this will allow, this statement will allow us to print in this format, N cross 1 equal to, and then this is N cross N into 1. And then N cross 2, which is like you will get this displayed, and then it will be N into 2. And similarly, N cross 3, N cross 4, and obviously you will write it for 10 times, right? So that will be nothing but the table of N. It can be 5, it can be whatever input that you get. So here what you're doing is like, you can see like you're using this print statement and so many times, right? Obviously, it's like right now it's 10 times. If somebody asks, like you iterate over 100 times that table, right? Not just 10 times. So you'll be writing those 100 such statements. I mean, it's ridiculous, right? Writing these 100 lines for simply printing this idea. So too much of repetition, can I avoid this? Can I do it in a better way, right? And therefore, a simple idea that we are going to do is we are going to do it in circle, right? In loop. So we'll be doing it every time, and there will be some stopping condition where this loop, this iteration that they're doing, this repetition is going to terminate, right? So what we do is like we start with, let's say, this counter, which is like we can call as a looping variable, because this will allow us to figure out that how many times I'm going to loop. I'm going to repeat that. So initially it is I equal to 1. Obviously, it is going to start from I equal to 1. Or you can start with I equal to 0, then your count should start from 0. So 0, then 1, then 2. So depending upon whatever you prefer, I mean, you can start counting from 1 or you can start counting from 0. That's either thing is fine, but you should be careful when you start counting from 0. Because if you count, your counter gave value is equal to 5, that means total number of counts are 6 actually, because you started counting from 0, right? So you can very well start counting from 1, just like the humans are very comfortable counting starting from 1. And then we will go up to when I will become equal to 10, less than or equal to 10. So this loop will continue till this I will take the value equal to 10. And if I become greater than 10, so it will take this branch. So you see, we have got this condition, which is evaluated, and this will evaluate it to be true for 10 times. When I will be 1 here, then it will become 2 eventually, then 3, 4, 5. In a minute, I will tell you that how this I will change one by one, right? So I will be getting incremented every time by 1, and that will indicate that we are repeating it that many times, right? So this condition, when evaluated to be true, which is I less than or equal to 10, then we got one part, and if it is evaluated to be false, then we will say that okay, we terminate this repetition with this loop, this iteration, right? So what we do, we are going to stop. But before we stop, we have to do it 10 times, right? So that's what we are going to do. When this condition is evaluated to be true, we are going to print this this expression which we have already seen. Print n cross I equal to n into I. This is an expression which will multiply n by I and give that particular element of that table, but this is what we're going to print, right? And we are going to now use this print statement only once. But since this print statement is being exercised multiple times, I mean, depending upon how many times this print statement is going to encounter. So it's a kind of like we are writing it 10 times, right? Whereas we have written it for once, and since this condition will be satisfied, will evaluate to be true when this I will be incremented. So what we are going to do inside the loop, I am going to increment this value I equal to I plus 1. And then it will go back again and will check. So initially I equal to 1. Then if I is less than 10, less than equal to 10, yes, then I'm going to print it with this I equal to 1. So n cross 1 equal to n into 1, which is n. So 5 cross 1 is like 5. So this is going to be printed. Then I is incremented by 1. So I become 2. This loop will go by default, I mean, to this statement because it's a looping statement. So it will go to this checking condition. Then I is less than or equal to 10. Still I is less than or equal to 10 because this now I equal to 2. So this will go again inside the loop. We'll print another this print statement with I equal to 2. So it will print the second entry in this table. And then again I will be incremented by 1 and will go back to this check. Again, this check will satisfy, that means will return as true. So again, like this print statement is getting executed. So this print statement will get executed 10 times because we have started with I equal to 1. And this I is incremented here every time until I is incremented till 10. This will evaluate to be true because I is less than or equal to 10. This condition will satisfy. So from I equal to 1 to I equal to 10, this branch will return true and this print statement will get exercised that many times. So 10 times this print statement is going to get exercised. And when finally I equal to I plus 1, when I become 11, right, then it will again go to check and it will check that now I is no longer less than or equal to 10 because I is now greater than 10. So then when I is greater than 10, this will evaluate to be false. That means this is the condition which we can call as loop is terminated. Loop is exited, right? Loop is completed. So the loop is completed and we then stop. So you can see here, this is a very simple idea that is being exercised here. That what we are allowing here, if a few statement here there are 2 statements, right, which is getting exercised multiple times. And therefore you are putting them inside a loop. But then you cannot loop forever. I mean, you have to decide that how many times it has to get executed. So one simple idea is to make a check here. So you set a loop by some condition here. So for example, this I equal to 1, that means you are ready to use a I in a loop where you are going to manipulate this I and you're going to perform a condition on I. And till this condition is satisfied, this loop will continue. And as and when this condition becomes false, the loop will terminate. So this is a kind of loop design. I mean, you have to design this this part of the code. Obviously, it's not very trivial. I mean, you need to think correctly so that this loop will execute correctly, correct number of times, and those statements inside the loop are, I mean, being performing the computation correctly. So you need to figure out that what will be the part of the loop body. This is also called this is also called as the part of the loop body or the code which is supposed to be executed when the control will go inside the loop. So when I say control, that is the execution control, it's another control flow statement. So now we have got second control flow statement, which is loops, because here the loop will decide either go left or go right, either go inside of the loop or simply go outside of the loop, right? So again, there is like a transfer of control and which will be decided based on certain conditions. Just like if statement, the transfer of control, the execution control was decided by the outcome of this condition. If it is true, then one part of the code will going to get executed. If it is false, and if you have else part, then else part is going to get executed. So you know that now in that sense, the loops are a control flow statement, right? So we have got two control flow statement. The third kind of statement, which is assignment statement, is not a control flow statement because this is simply assignment statement. And whatever is the following statement after the assignment statement is going to get executed anyhow, right? So there is no transfer of control, no change of control, right? No branching out there. But here in if statement as well as in loops, we have this branching statement. I mean, these are called typically branching statements or control flow statements, right? Right. So how we are going to write that in the code? So what we're going to do, just like we'll take this input and whose table is to be displayed. Then we'll start with I equal to 1. And this is the loop. Now the loop is syntaxed as with this name while. So first kind of loop, because there is another kind of loop which is for loop. So that's why you should be now able to figure out that there is one kind of loop is while, another kind of loop is for, and why these two different kind of loops are used. In fact, in some other language like C, we have got three kind of loop, which is like while loop is there in C also. For loop is also there, and then there is a do while loop, which is not here in Python. So that gives you some idea. You may speculate at this point of time that the loops, there should be two loops or three loops, or there's like there can only one loop which can satisfy the need of the programming. I mean, when we solve problem using writing program in some language, is this language supposed to use two loops or three loops, three different kind of loop, or four loops or one loop? So I can tell you like that's like fundamentally one loop is good enough. And we will see that here in Python also. I mean, this will be very interesting to figure out. Though we will solve some problem using while loop, some problems using for loop, and we will also figure out that when to use which loop. But in principle, you will see that we can replace one loop with other loop. That's possible. So why there are two loops for people to use and for them to get confused or to make their life more difficult? Not really. You will see that one kind of loop, this out of these two loops, there's like a while loop here, and then for loop we will also discuss. So we'll find that given the problem scenario, there will be a natural idea to think that I will use while loop or I will use a for loop. And very soon this distinction will be clear. But again, I repeat this, that it is possible to use only one loop to solve all your looping part of the code, right? So absolutely, there is no necessity of using multiple different kind of loop. But since in programming, people also think of flexibility, also think of capturing the intuition and coding that intuition directly in the code and having code more readable. And that's why we have these two different kind of loops to be used at different times. But one loop statement can be good enough for solving this looping part of the problem. I can tell you this, and we will see that, right? That it is possible. So having said that, any of the loop will be work. First, we will discuss about the while loop, how it is to be used. Then we will discuss about the for loop, how that for loop is to be used. And we'll have those arguments that we can replace a for loop with a while loop or a while loop with a for loop or vice versa. That's not a very important argument here. This flexibility of having two different kind of loop is just for the use to make things more look natural, more look simple to follow, and that's why these two different loops are included. Otherwise, we could have simply have one simple loop, right? So, okay, so how this while loop is being used here, right? So you see, while we design the solution of the problem, that multiplication table, right, printing the multiplication table, what we have seen that we will check this condition. So while, and then we have this conditional statement. So while is the keyword which you need to put when you use while, followed by this expression, right, which is a conditional expression which you have already used it, right? Now you know that where you used a conditional expression, you've used them in if statement, right? So there's like same kind of statement whose result is going to be either true or false. So what we are going to have here in this conditional expression, either true or false. That means based on this, while if it is true, right, while this is going to be true, then we will get inside of the loop, just like while just like if statement, that if condition met, then you go in the true part of that if statement, else you go in the false part of the statement, right, which is else part, right? So here also we have got this true false result of which will be like obtained from this expression. Right now, very simple expression, you can write very complex expressions as well. So very simple idea and a very similar idea to what we did in the if statement, because we will check a condition here. If it is true, we'll go inside. If it is false, we'll go outside. When we say we'll go outside, that means that is the termination of the loop. Because when it will go inside, it is nothing but a repetition, because this condition will be checked again when we go inside. This is the code inside. You can say that this is the vertical alignment. This is the colon. Colon suggests that this is like the following is going to be the body of the loop. This is the body of the loop. Here, two statements. This vertically aligned, right? And the third is not vertically aligned because of that statement is outside of the loop. You must be now very much familiar with this idea that indentation in Python is very important, and it can cause problems also if you are not careful in writing your code, right? People who did some programming, let's say in C or Java, they might be familiar with this block statement, right? With this curly braces and all those statements inside that block. They are considered as code block. But here, the code block is nothing but all those statements which are aligned vertically, right? In the same alignment. So this is this. So here we don't use this curly braces. Rather than we use this simple idea, but important idea which need to be taken care of. That if the statements are vertically aligned, we'll consider that as a block. So obviously, each mechanism of defining a code block has its advantage and disadvantage. Similarly, Python has its advantage and disadvantage. So you should be careful. Only thing is we need to know that how to define a block in a programming language, right? Block of statement. When we say block, it's nothing but a set of statements grouped together. So they will be either executed in that sequence, one after another, or will not execute any of this sequence, right? So that is one block of statement. So here, this body of this while is nothing but again a block of statement. So like vertically aligned. And what will happen that when this condition is satisfied, that is true, we will use this term, the condition is satisfied. That means condition is found to be correct, means found to be true. So if it is true, then the control will go inside. That means the body of while statement is going to get executed. And so this statement will get executed, followed by this statement get executed, and there is no other statement followed by the second statement, right? So what will happen? The control will automatically go back to the stop, which is the condition part of the while statement. So this is the iteration. This is what the looping is, right? This is what the looping is. This is what the iterations are, right? Repetitions are. So the last statement in the while, after that, the control will go back to check the condition. If the condition is still satisfied, the true, then it will go again inside the loop, will execute that code and will go back again. So this will be continued till this condition becomes false. So there's one very interesting thing that you can figure out, that if the condition never becomes false, then what is going to happen? Then this loop will execute indefinitely. That means your program is not going to terminate because your program is running. This loop is going on. statements are getting executed inside that loop and so on and so forth. So, and it is not getting terminated. So infinitely, for infinite time, it can run if you don't terminate it forcefully. Obviously, some environment in Python, they takes care of this situation because if sometimes like if some loop is taking enormous time, then it will terminate after some time, right? Forcefully, it will make this program to terminate, like this whole program, and which we can call as crash. The program is crash. So this is which we should be very clear here when we are designing a loop, that we have got this loop board. This loop will start with while, then we have the conditional expression, and this condition should become true as well as should become false. At least it should become sometime false, otherwise the loop will not terminate. So it is important to design this condition. I mean, to be very sure about that this loop is going to terminate. Because if the loop is not going to terminate, then it will continue forever, and that's for you is like a kind of problem for your code because it is not getting finished, right? So while you design a looping state, you need to be careful about this conditional expression and all that computation that you perform, so that this whole loop will be carried out correctly. Depending upon the number of times these statements getting repeated or executed again and again, the overall result of this loop should be correct, right? And that's why designing a loop is, I mean, you have to give some brain to it when you use loops in your program. Just like you might have used if statement, if else statement, and you figured out that how to use them, I mean, what condition is to be provided, or if you might have used nested if inside if, then what logic will allow to go inside of the first if or the second if or so and so forth. So that kind of understanding, that kind of design in your mind, and then putting in the like on the code, right? And then running it and looking at and verifying, ensuring that this construct, whether it's if statement or loop statement, that is correctly placed, right? They are correctly executed. So it's a more of like logic design for both if statement and the loop statements. But if you can do it correctly, then probably you're going to solve that problem. So now we have got three important statement. Assignment statement, it's very straightforward. Conditionals, which are again not very difficult now. Now you are already exposed to, and you might have already used it multiple places and solved a few problems, and you find comfortable to use if else, if simple if, or if else, or if elif else kind of statement, or now this while loop. So this week topic, obviously these loops are these loops, and we will be using these loops, while loop as well as for loops, and we'll solve some problems, and we'll see that they're again not a very complex idea, simple idea. These statements allows us to think of designing the solution of the problem. So you got three kind of statement. We got assignment, you got conditionals, you got loops. Now what you do, when you write programs, you make use of these statements, right? You put them in some sequence, right? And that in some sense like getting the logic of solution getting embedded in this programming language. So you've got something in your mind, some logical solution you may work out in your mind, or you may have used a piece of paper where you might have designed this flow. You might have written some rough draft of the code, right? And then you started writing the code in actual. And then after some time, when you finish, you execute that, to run that code and see that whether it is correct or not. So when you write programs, obviously we don't write all the code at once and then we run it. Obviously, it is more of like incremental process. You write one statement, maybe two statement, and then you run it. You write a print statement to check whether up to that point of time it is giving me correct results or not, or whatever my intentions were to make those computations operations, they were performed correctly or not, so you can get them printed. And then you add some more code, and then you add some more code, and again run this program. So coding is done incrementally by figuring out that whatever is the logical solution, right, that you could have figured out. You can test this by writing the code incrementally, running it intermittently, and checking results that whether you are going in the right direction or not. Anywhere, anywhere, anytime you figure out that there is some issue, you go and check your code and figure out that if you are making some mistakes here, right? Or your logic is, whatever your logic you might have thought might be incorrect. So this is a very interesting way of solving problem, right? Where we get some logical solutions in our mind. Now we convert that logical solution to this set of statements. And there you are given these three kind of statements, right? Which you can use. You can use them multiple times and in whatever order you want to use them. That's perfectly fine. But it is you to figure out, to map your logical solution which you have in your mind or pen and paper, which you have come up with. You have to put them into sequence of those statements, which is consist of assignment statements and loops and conditionals like if statements, right? So you need to put that logic, you need to put that solution which is in your mind or in a piece of paper which you work and design that solution, and then now you have to convert that solution into this statement. So those statements must in a sense like get that idea embedded in the code. That's what we say that coding, right? So that you had some solution in your mind, now you're coding it. Now while you code, I mean, you have to act sensibly, you have to act responsibly. These are all tools which are given to you, right? But then you have to use them sensibly, you have to use them meaningfully so that you can write a correct solution on the problem. Okay. So indentation is important, is like which we have used with if statement, and now it will be used with the while loop also, and you might have used some user defined functions also. So there you have seen that aligning all that code which is inside the function is very important, so that alignment allows us to figure out that what is inside the function and what is not. So it's indentation, whether it functions or if statements or if there are loops, you need to be aware of them, that how do you use this indentation to figure out this code block. Again, like this is an example which will suggest that this part, this is the indentation. So this suggests that this is the code block, which is the true part of this condition if statement when it is evaluated true. So that this code block, which is consist of only one statement, fine, you can put more statement aligning with this, that's again fine. So that is the code block, that is the vertical alignment, and that is the indentation, right? And then the else block is this, right? And if you are putting all these statements here, so they are all the part of else block, right? So if this was out of this else block, but then if you put in this alignment, then the compiler will consider this as a part of else block rather than the outside of the else block, and that is the problem, right? So I mean, this intent, this actually should have been outside is the minimum, right? But then incorrectly, if you put aligned with this, then the syntax or the semantics of putting them in this vertical alignment, having the same indentation, is that this code is one single block, right? So we'll execute all at once and not. So whatever the previous statement belonging to, this next statement also belong to the same block, right? So that's why this else is, if you put in this way, then this print statement is inside else and it's a part of else block rather than if. So if you want to keep outside of else block, you have to bring it here, right? And align with the main program alignment. So that will go outside of the else block. So it is us to figure out, right, these kind of issues. I mean, you are going to write the program, you are going to make those kind of mistakes, and you are going to correct those mistakes also. Sometimes these error messages which you get are very useful, but sometimes you may have figured out by now that sometimes those error messages are not really giving you the exact location or the nature of the error. So you may have taken some more time to figure out that what was wrong, and you might have fixed that eventually, but it could have taken more time. So error messages sometimes can be funny. I mean, they may point to some other and may misguide you, but then this is how these error messages are, and we have to live with them. But with our experience of writing code and encountering all those error messages and then correcting the code will make us very much familiar of those error messages and making them and dealing with those error messages very quickly, correcting the or fixing the bug or fixing the issues, and it will be done very quickly, right? And you will be much more comfortable. So programming you cannot learn by just reading books or reading code or going through internet videos and all. It has to be done by doing it. Until unless you do it, you feel it, you get into the water, then only you can swim in, right? You cannot swim by, I mean, you can learn swimming by being outside of the water and going through a lot of reading material and all those kind of things, right? So similarly, programming, you have to do it, and that will make you more comfortable. The more you do it, the more you will be more comfortable. And this is how, after some point of time, if we see that one student is much better in programming and one is less comfortable, or is like not able to cope up, the difference lies only that the one who is ahead, who is now found to be good, has done a lot of coding, right? Has gone through all those experiences, and now he's therefore his confidence, and the other one has not gone through those experiences, and therefore it's lacking on those kind of things. So there is no shortcut to programming, just like there's no shortcut to swimming also, and for that matter, any those kind of skills that you need to acquire, right? Then only like painting or vocal music or whatever, like playing some instrument or all those. I mean, you have to do it. You have to do it, right? And a number of times you have to do it. I mean, you have to put a lot of effort. So even if like this is one of the course and you've got 5 courses, and some of the smartest of the people among you may think of like I have, I mean, let's say 10 hours of study and I have 5 courses, I'll give 2 hours to each of them. I mean, for programming, this may not be a correct idea. I mean, programming requires a lot of effort. I mean, you have to work on weekends, maybe, I mean, hours and hours of like coding will allow you to become more comfortable. But this skill is very important because it's like one time you get this skill, the rest of the life is going to be very huge, like you can say trouble free, or will be much easy. Else there will be problem. So if those who are thinking that this is one of the course and I will be giving only that much of time, that proportionate time, I think you are mistaken here. For programming, you must be putting some good amount of effort, and that is uncomparable with the effort that you will put in the other courses in the same semester. Please don't do that kind of mistake. Do programming. I mean, initially it will be slightly difficult because your experience is not there, but gradually as you will become more experienced, you'll find that this is very simple. People, you might have learned driving, car driving or any vehicle driving. They might have initially figured out a very difficult thing. I mean, how to control this vehicle, steering and all that, and might have like issues, like quite a fearful thing at the beginning. But those who have learned, I mean, just ask them how simple this idea is. It's only the experience, right? Only your familiarity, your exposure to those kind of things, and once you become like confident of, like you can solve any problem. That's right. So while statement that we have already seen, right? So what it is going to be, we have that expression. So this is a general form, right, of this statement, which will start with while, and then there will be an expression followed by this colon, and then we will have some indentation, some space, so that all the statement that you're going to write after this indentation is going to form the body of this while loop. When this condition is evaluated to be true, the body of the while loop will be getting executed. And when it is evaluated to be false, the while loop will terminate and the next statement is going to get executed in this sequence, right? So this is how it is going to be, right? So it's so in a logical sense, we can think of like the expression is evaluated. If it is found to be true, then S1 is executed, S1, or there may be many other statement also. I mean, you may think of like this is like the inside the body, inside the forming the body of the while loop. And then once all the statement got executed, then it will go back and check this expression again. And if it is still true, it will go back. It will execute this and will go back again. So this looping will continue. This is what the loop is. All these statements will execute multiple times, right? One after another, till this expression is evaluated to be false. And once it is evaluated to be false, then it will come out, what we call this term as come out of the loop. Loop is terminated, and normal execution after that statement will continue. So while is just one statement, just like if statement, and the following statement will start getting executed once while is completed. So all this like is nothing but, you know, that we write the program one statement at a time, right? And these are all arranged in that sequence in one after another, right? So when you run this program, the first statement will execute, then followed by second one, then the third one, then the fourth one. So if this while is not in an infinite loop, right, which is a very, very interesting situation where this expression never turns out to be false, then the while will continue to remain in the loop and this loop is not terminating. So all those following statements after this while is not going to get executed. And your program is not terminating. I mean, that's an error condition, and that's the issue in the program. You have to go and fix your program. You have to terminate your program forcefully, and then you need to check that what is wrong, why it is not getting terminated. So there may be some condition issue, some checking condition, some expression which is incorrectly written. So you can figure out eventually. I mean, this is all simple things that we can. So we have seen this example. Let's say we'll take another example. Read a sequence of integer from the terminal until we get -1 is read. So what we are going to do, we are going to output the largest number read so far. Now the problem, just think about this problem. What is the problem? Again, let's rephrase this problem. We'll get some numbers one after another from the user until we get a -1. So all those numbers we are going to get, they can be 2 numbers, they can be 10 numbers followed by -1, they can be 100 number followed by -1. And what we are going to do, we are going to find out the largest of those number inserted or inputted by the user, given by the user, right? So I think the problem is clear. And this problem scenario, if you just analyze this, that you have to read numbers, right? And you're not sure. I mean, how many times you need to read this number? There can be as and when -1 is encountered, then that is the point where you will stop reading the number further. Otherwise, you will continue to read. So it's a kind of like you have to repeat this reading multiple times, and we are not sure how many times we need to read. But then we know that as soon as we encounter this number as -1, then we will finish and we will stop reading it. And we are going to output the largest numbers so far, right? All those numbers which were inserted before -1. What is the largest number? So this is very interesting problem now, Sandra. So without a loop, it's very hard to figure out that how we will solve this problem. I mean, can you solve this problem? Let's think about it without using a loop. I mean, you are asked to read a few numbers. Now, I'm not saying how many numbers. The condition is as soon as this next number is -1 or any number in this reading process turns out to be -1, then there is no more reading. And all those numbers which have been inserted before, I want to get the maximum of those numbers. That is the problem. So largest number reads so far, right? All those numbers. including -1 or excluding. This will be again very interesting proposition, but we'll come back to this point. For now, we can, let's say, exclude this also, but we can include also, right? So the problem statement can change. You know, this is one problem statement. Another problem statement can have like excluding -1. So what if we include -1 as a number, right? And what if we don't include this -1 as a number? So it is going to give me different results for different set of numbers, right? So now we see this scenario, and we are sure that since we have to repeat some task, that we have to repeat the reading numbers, there is this one task, and we have to also repeat to continue to check that if this number which we have read so is the maximum of the number which we have already figured out, right? So what is going to happen? I mean, just think about this, solving this problem, a logical solution in your brain, how it will come. So let's say I read this first number, which is, let's say, 5, right? And what is the maximum number so far? If I read 5 and then I put -1, right? So I am only one number. The -1 is, let's say I use this excluding, right? So -1, I am not going to, this is just a termination criteria, I mean stopping criteria, but I'm not going to include it. So I have just one number, and maximum is 5. So what I'm going to do is, like, as soon as I'm reading this number, I'm also comparing this number with the maximum number. Now, how this maximum number is going to be stored? So as soon as I read the first number, I will consider that as a maximum number. Because if it is the only number, then I have to output that number. And then I will wait for the next number to come. If I read after that 5, I read 10. Now 10 is the maximum number. 5 is not the maximum, because now I have got 5 and 10. So what I'm going to do, I'm going to compare this maximum number, which is 5 currently, I mean, after first iteration or first input I got. Now I will check this first number or this maximum number with the this number which we have just inputted, right? And we'll check that if the 10 is more than 5, if yes, then I will make my maximum as 10. And then I will look for the third input. And the third is even bigger number, then my max value is going to update by the third number, and so on forth. If I get the fourth number as the lesser number, then my max number is not going to get updated. It will remain the previous max. Right? So this is how I'm going to take all this number one by one. And in this process, we'll make a check that if the current max, which I'm going to call it current max. So that current max is nothing but one variable which is going to store the current maximum value encountered so far. And every time I get the next number, I can compare it with the current max and can figure out that whether I need to update my current max or I can continue with the previous current max. Depending upon if the next number or this new number is more than the current number, then I'm going to update the current max, or I'm going to continue with the previous one. And I will continue this process till I'm going to get this -1. So this including and excluding will be two different scenarios, where in one case I'm also going to compare this number with the current max, and in another case I'm going to ignore this comparison, because this -1 is just for termination, just for the stopping. So what I'm going to do, I'm going to take this input number, right, read the first number, and now I apply this while loop, because let's say if the current number, let's say if we use this including, right? So this is interesting to know, right? So I'll go with this, right? So while n is not equal to -1, that means if it is -1, then terminate. And just recall this. This is a Boolean expression, right? Conditional expression, and the result of this can be true or false. So if it is true, then the loop will execute. If it is false, then the loop will terminate. So if n is not equal to -1, let's say Pele number, like it turns out to be -1. The first number is -1 itself. right? Then n is not equal to -1, which is turned out to be false because n is equal to -1. So that means loop will terminate, and I have to report this including, I mean, when I include it, then maybe this number is the maximum number because this is the only one number I got it, and it happened to be -1, and I have to include it in this ranking process or find max process. So I will report this -1 as the maximum number. So, but this is for general case, and we'll come back to this situation where the first number happened to be -1. So what will happen? Let's say if it is not -1. So general case is, let us assume that this first number is 5, the second is 10, third is 8, maybe -10, not -1, right? So there can be minus numbers, negative numbers, there can be positive numbers, bigger, smaller, all of that. And then finally we are going to get this -1, right? So till it is not -1, we are going to take this more number, right? This is how we are going to take more numbers, right? But where is the logic which we are going to put in, right? So this loop will suggest that we can take numbers one after another. We can take first number and check it in this loop, and we can get more number in this loop. So this will address this problem of taking these numbers multiple times, right? And figuring out that if it is -1, if it is -1, then we will no more take this input, because this will turn out to be false, and therefore the loop will be broken. This the control will come out of this loop, and out of loop means all those statements following this while statement is going to get executed. So this statement will be bypassed, which is inside of the file, right? So no more further inputs are taken. So that logic is perfectly embedded here, that we can take numbers one after another, and at the same time can figure out if it is -1. If it is -1, we stop taking them. But where is the rest of the logic? I mean, we need to figure out that which is the maximum number out which we have, right? So this simple loop will suggest that we can take numbers we can take these inputs multiple times, right? Unless we get next number as -1, right? Now this logic where we want to find out the max number. So what I'm going to do, I'm going to put here one variable max, and I'm going to assign this as n. So what this I'm doing here, I'm taking a number, and additionally I'm also like putting that as max, because whatever this number is, this is the first max number, right? If this is the first number, it is the max number. Even if it is -1, then it is maximum, right? So I've got this solution here that now max will store the number which we taken as the first time, right? And after that, when I take more number in this loop, right, I'm going to update this if needed, right? So what I'm going to do, I'm going to read more numbers. So I've read next number, and now I'm going to put this if statement here, which will figure out that if this number which we have read, and now this number is stored the second number, right, when inside the loop, right, for the first time, right? So if this n is greater than, let's say, max, right, then I'm going to make this max equal to n, right? So what I'm doing here, I'm taking this next input, and now I'm comparing with this my max, which is for the first time when I am inside the loop, the max equal to this. But next time onward, since I'm updating this max, then that max may come inside from the numbers which we have taken inside this loop, right? So if n is greater than max, then I'm going to update this max equal to n. Else I'm not going to update anything, right? Because max is remain max. So if the number that I've got next, right, which will be a different number, obviously, right? And I'm going to compare it with the max, and if this number is greater than max, then I'm going to update this max with this number. Now my new max is this number. Else, so if this condition is not satisfied, that means whatever max is there, it will remain max. Now, so this is what will, so this will continue. If this is greater than max, then we will update max. Else, if it is this condition is not satisfied, there is no more statement here. I mean, this will go back here. We'll check about whether this value which we have taken, right, is -1. If it is -1, that means we need to terminate this loop, right? And if it is not -1, then we'll go inside and we'll take next input and we'll check again and we'll update this max if needed, and we'll go back here and check this number. If this number was like -1, so you can see here we can continue and we can solve this problem, right? So this code is included in the our demo code, and you can go through this code, and you can also see one by one, I mean, how these instructions are going to get executed. So every run of this loop is called an iteration. So if we go inside of this loop once, this is called one iteration. Go again in this loop, this is another iteration, third time, third iteration, fourth, fifth, also called repetitions, first repetition, second repetition. But iteration sounds to be more formal term, which is typically used in when we talk about loops, and when you read those books or some material on internet, you will find they use term iteration. So this iteration is nothing but the number, the repetition, the number of times we repeat. So one iteration is one time, two iteration 2 times, second iteration is second time, third iteration third time. So iteration is like, and there is no more iteration after 1 point -1 is read, right? So this, you know, that as soon as this condition tends to be false, there is no iteration, because no iteration means since it will not go inside the loop, and therefore no iteration. So let's say if you take this 3 number, 4, 15, 5, -5, then you take 4 here, then while n is not equal to -1, this is true because n is 4. So n is not equal to -1, right? It's true. And go inside. So one iteration when it was 4, then it will go back, right? And make another iteration when it will be 15. Then it will go back and take one more input, -5, like third iteration, right? And then there is like -1 is read, right? Then after that, it is not going to get inside, right? So you can see like we got this problem solved, which is like finding the maximum distance. There are 3 components of a while loop. One is initialization, right? Then initialization is where we have put like I equal to 1, because this is what the loop variable is, and typically a loop variable is going to get updated inside the loop so that it will eventually ensure that the loop will terminate. If it is not getting updated, then the loop will not terminate, obviously. So there is like some initialization. So here we are reading it and we are checking I equal to 1 also. That is the initialization part. Then we have the condition, which is this part. And then we have this update, which is like the body part of this. So there are 3 components of the while loop, which is like. There are common mistakes with when we use while loop. Maybe like not incorrect initialization, or that the update step can be skipped, right? You might have not doing correct update, and therefore it may go into infinite loop, right? So update step must ensure that we are moving towards the direction where eventually this loop is going to terminate, and therefore rest of your program can execute and finish correctly, right? Incorrect termination condition, there may be some condition where it terminates, but the condition might be incorrect. So it can terminate early, or it can run more number of times than desirable, and even it can go to infinite loop. So there are the places where we need to be careful when we make use of. And if your loop is not working correctly, you need to check these points, these places where you can figure out that this is the issue with this. Right. So there are some more problems here for. Let's say this problem, given a positive integer n, print all integer less than or equal to n that are divisible by 3 or divisible by 5. Right? So what you're doing, you're taking an input n, then you're going through all those numbers from, let's say, 1 to n, and you need to report that which are like that are divisible by 3 or divisible by 5. Right? So you have to report those numbers which are multiple of 3 or multiple of 5 in a sense, right? So this program requires to output those numbers which are less than n and divisible by 3 and divisible by 5, right? So you can see it's a simple idea. You will take this n equal to, let's say, input, right? And now you start with this loop initialization where you set x equal to 1 and you are going to increment x, right? When till the point when x become equal to n. So what you are doing is like you are starting with the x value x equal to 1 and you will go up to x equal to n, and therefore you are going to have this update step where you are going to increment x by next number, right? So that you can iterate over all those numbers, you can go through all those numbers from 1 to n, and then you can check this condition if x mod 3 equal to 0 or x mod 5 equal to 0. So when it is 0, that means they are like multiple of 3, or here it is multiple of 5, because the remainder is 0, right? So if any of these conditions satisfied, right, this or, this is a Boolean or, right? So if it is either this true or this true, then the whole expression is going to true. We are going to print this. This is all inside the while mode. So this is another example of like using while, right? Now for loop, this is another loop construct which is included in Python, right? Let's say you want to do this solve this problem, print the sum of the reciprocal of first 100 natural number. So you want to print, let's say, like 1 opposite inverse of 1 is like reciprocal of 1 is 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4 plus dot 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 plus 1 over 100. So let's say you want to print the sum of this, right? So again, this summation process, 100 number, right? Obviously, you can write this expression where we can simply use this arithmetic expression where 1 plus 1 by 2 plus 1 by 3, and you can write this expression which contains this 100 elements using joined by this plus sign. So there will be 99 plus signs, and this is very big, large single expression, and that can also solve this problem. So without loop, you can solve this problem. If I ask you like to do it for 1,000 natural number, you can write it for 1,000. If I ask you 10,000, you can write it. And a million, I mean, why you will be doing this kind of silly stuff, right? Writing this time. Why not you are going to do, you know that you're doing it again and again, and you can do it for variable number of times. So why not to do it in the loop and figure out that how many times we have to do it at any given point of time for a given problem, right? So in this problem, it is 100 times. So my loop will run for 100 times, right? So what I'm going to do, because I have to calculate the sum of the reciprocal, I will use a variable which is eventually going to store this sum. Reciprocal sum R sum, I have given this name. And initially it is 0.0. And it is a floating point number because we know that this is a reciprocal which is 1 by 2. So this value is going to be real number or floating point number. So that's why we are going to store this. This number is going to be this real number, right? So I'm using this So this is the initialization part, part of initialization step. And then we are going to go for 100 times, right? So maybe we start with I equal to 1, right? And then I will take a while loop also, and I can write a for loop. But let's say I use this time another loop construct because it is given to me. So this loop construct suggests that you start with this for, which is a keyword. Then this is I, which is the looping variable. Then in, this is a keyword which will see that in this part of the statement, it will figure out that how many times this I need to go through. Right? So here, this is the range function. So I don't know whether we discussed this range function. So this is simple function which will return numbers between, like, so it has three values, range function, like initial value, so A, then we have like final value, then let's say F, and then we have this increment. So it will start from this value, will stop before this value. This is not included, excluded, and it will increase every time. This value will increase by this increment. So it start with 1, and there is not, since their third variable is not given here, right? There is no third variable given here. So we are going, so default is 1. So it will, next time it is going to go 2. So this range function will return numbers from starting from 1, then 2, then 3, then 4, then 5, then 6, and up to 100. 101 is excluded. This is excluded. So this is 101. So it will go, I will go from 1 to 100, 1 by 1, 1 to 100. That's what this range function is going to do. So what this loop is suggesting here, for I in range in this expression. So this can be a list, and when we will discuss about the list data structure, you will find that this particular part can also represent a list or a collection where I will go through each element in that collection, each data in that collection. So this is a flexible part of this for loop. You can specify that what is to be done. You can give a list, or you can use this range, right? You have to give you some expression or some code which will return you those numbers, multiple values, right? And you're going, this I will go through one by one all these values. And then what I'm doing here, rsum equal to rsum plus, so previous value of rsum, and then we are adding with the next reciprocal number, right? 1 over that I. And here I am writing 1.0, that's fine. Right? So that to make it very clear that these are floating point number. Even if you put 1 over I, the results are not going to change, because this is a floating point division, not an integer division operator. So we can now here, what is happening, this statement inside the for loop, again, like this column and inside the for loop. So this is the inside for only one statement. And what it is doing, it is adding the sum obtained so far with the next reciprocal number in that sequence, right? So we have this sequence, right? One after another, 1 plus 1 over 1 is like 1 plus 1 over 2 plus 1 over 3 plus 1 over 4. So anytime this loop is getting executed, let's say it is executed for the first time, then I equal to 1. So this part is become rsum. Next time this part and this part, next time this part and this part. So you can see like these two are already stored in the rsum in the previous iteration, and now the next reciprocal got added. So we got this part, and then next we got this part, and then this part. So gradually you can see that all these elements or this reciprocal elements in that expression is getting added one by one. And at the end of this loop, which will terminate when I will become 101, right? So then it will terminate. It will not go inside of that for loop. And so the following statement is going to get executed. This print statement will get executed, and you can print this also. So using only one statement inside this for loop, using this for loop, you have solved this problem. So you see again, that's something which we need to do it repetitively. How here, how you can figure out that this task is repetitive? This very big expression of adding those 100 reciprocals of the first 100 natural number. How it is repetitive? Because this is first number is 1, then we add the next reciprocal of the next number, which is 1. This will be like 1 sum, and then we have this like 1/3. So this, then again we have to add this. So this is already added R sum, and then we add this next number, and then we have 1 plus 1/4. So this can be added and stored in the R sum. Then we have 1/5. So the previous R sum plus the next. So we are repeating this, like every time R sum is having updated, and then with the next value of in that sequence, right? So this is how this task is a repetitive task, and that's why we are using this for loop to do this task. Now here you can see this for loop, because we know that this first 100 natural numbers. So since we know that we have to do it for 100 times, right? Maybe this number itself, I can take input from the user and can decide that how many times. So this reciprocal of how many numbers, 10 number, 30 numbers, 100 numbers, 10,000 numbers. So if you want this to be also controlled by user, by giving this number, that how many numbers to be used in this summation process, right? Or how many natural number to be used, if you are asking from the user, then this second variable here, this value can also be substituted by a variable which you can take as an input, right? So you can take that as an input statement and then put it, that you can substitute here, and therefore now this will go user defined number of times. This is how we can control the loops which will run different times for different problems. Right? So for loop in Python, the general form is for variable. This is like we said, so the looping variable in sequence, and that part is the sequence. So range return a sequence, which we have seen range function. So you can play around with range functions. I think we have used earlier also, but in any case, like it's a very straightforward function, is return number of values in a sequence, or there can be many other sequence like list, right? Tuple, and we'll see that these sequences, how we can use this. So all these sequences, and a very simple idea to use range functions if we have to do it in that many number of times, right? So simple use a range function here, which will return a sequence. And for all those elements in that sequence, these statements are going to get executed one after another. And once this this sequence is exhausted, completed, we have done away with all the elements in that sequence, we can move further. So that loop is terminated automatically. There is no condition to check. The condition is only that the sequence is exhausted. So you see, this is a different proposition here, right? Here we are taking a sequence and performing some operation over all the elements of the sequence, or against for each element of that sequence, we are doing something here inside the form, inside that loop. And that's what this for statement is, for loop is. So for is again a looping statement, because we are repeating some operations here, which is the body of the for all the elements in that sequence. Whether we are explicitly performing some operation with that sequence or not, that's a different thing, right? It will depend on the kind of logic that we would like. But we are doing that for this, that number of times, which is nothing but the number of elements in that sequence. So this is how this for loop can be used. So we have got two loops, for loop and while loop. We can take some example. for evaluate the sequence to get a list of values. If there are more values in that sequence, then it will continue with each of these values. Otherwise, it will exit from the loop, right? So it's like it will go inside of the loop when it will continue to have those elements in that sequence, right? And yeah, and this variable, which we have seen here, right? It's going to get one element in that sequence each times in that sequence, right? So if that range is going to give you numbers like 1, 2, 3, 4, 5, 6, and so on and so forth up to 100, then this variable which we have seen in the previous example I, so if in the first iteration I will take 1. So here this is kind of implicit assignment. That there in while loop you need to use the I equal to 1, then you have to update this I. Here what is happening that this I is taking those values implicitly one by one, right, in that loop. So initially I will be 1, that is the first element of that sequence. Then next in the next iteration it will take the value 2 and 3 and 4 and so on and so forth. So same problem that we might have solved, like finding the minimum or maximum of a given number or summing up all those numbers before you get -1. We can do it here also. And it will be very interesting how you can use while loop or for loop, right? Though it will be good to use a relevant loop, relevant sounding loop to solve that problem, that scenario, right? So for example, if you have to do it in some definite number of times, if you know that I have to do it 100 times, you can use simply a for loop without actually using the while loop and then incrementing this I explicitly. And so that makes things very simple and readable, that this for loop is for fixed number of times. When we have to do something in a fixed number of times or predefined times, which we can generate in the program and can run a loop in that number of times, then it's a predefined number of times, and then you can use the for loop. But if you are not sure that how many times you need to carry out this iteration, then while loop is a better choice, right? And this is what therefore these two different loops are. Right. So here in some animation is provided you that let's say if you start with this code r sum equal to 0.0, then phi is in the range of like 1 to 5. So it will start from 1, will go up to 5, but then I is not going to take 5 inside the loop. And the 5 is a termination condition here itself, right? So I will take initially 1, then the second iteration it will take 2, then 3, and then finally 4. When I will take 5, then this loop will terminate. That's what the terminating condition is, right? A default implicit terminating condition that is built in here. So here you can see in that sense, for is a safer loop because for is going to terminate when the list or the sequence is a finite sequence. But if this sequence is infinite sequence, just think about it, then the loop will continue for that. So this will be interesting to figure out that if this sequence is finite or is it infinite, and there you can figure out that whether this loop is getting terminated finite number of times or it is executed infinitely. So here you can see this range function will return this I1 in that sequence. So this will return this numbers in that sequence 1, 2, 3, 4, and I is going to take 1 at a time, right, in that loop. So initially I is going to 1, so 1 over 1.0 over 1, that is going to get in. So that is what it's like. So you can start, we have got I, and I is going to take this 1 initially, and the R sum is 0.0, which we have already seen in the previous statement, Ajay. Then R sum will be updated here with this value 1 over 100, and that is going to be 1.0 because this result is 1.0 and R sum is 0, so 1.0. And then this loop will go back. So this is like go back is like default. Right? This is what why we call them as a loop statement, that after last statement, they go back and loop further, right? So in the while case also and in for case also. And then now here I is going to take value 2 because now the second time it is going inside, and 2 is a element in that sequence. So it will take 2, and then 1/2 is like 1 plus 1/2 is like 1.5, and so on and so forth. So you can see like this is going to get iterated one by one. And when I become 5, it is going to terminate, right? So I will actually not take the value 5, right? It will not go inside. I mean, we can say in principle that when this will become 5, I mean, after 4, the next value is 5. So y is not going to get exercised, right? So it will go up to 1, 2, 3, 4. It will take these values only. This is the sequence. 5 is not included. So it will not go. It's the last increment or last iteration was when I was 4, and now the sum will be updated when I was 4, and then the loop will terminate, and the sum will be printed as also. So range function, right? It's a very useful function which has got 3. I mean, this function actually comes with 3 parameters, but you can give optionally, right, these parameters. So you can give 2 parameters, then by default this d will be 1, right? You can even give only 1 parameter, which is like, let's say, range 10. So the initial will be so initial value it will take as 0, and then it will go as 1. So when you give only one with one variable or one parameter, then this will be determinating. And default it will start with 0. The default increment is 1, and so on and so forth. This is how it is going to. So as I said, without giving the third one, it is equivalent to this function, right? And range E, if you don't give any other parameter, just one parameter, then it will start with 0, and this E will be terminated, and increment will be 1, right? So actually it should be like 0. Terminating condition is when it will be E and then incremented by every time by 1. There's some more example that you can work out yourself. Like you might have solved like those problems, arithmetic progression, geometric progression. I mean, it's straightforward. Those are the parameters of the problem. For example, geometric, you have this R number, R, real number, and A, which is the first element, and the number of elements in that geometric progression. And you can actually solve those problems by asking the value of A, R, and then N, and you can apply that in the formula and can compute, and you can generate that kind of series. So when you take this N, I mean, you can print those series, you can do the sum of all those series, and all those kind of stuff you can do using while loop or for loop, using a loop statement, right? Interestingly, you can obviously, just like if nested if within if, you can have nested loops. So again, I mean, this having loop within loop will enhance further capability of those loops. But then at the same time, you need to be careful, right? When you use those, because these are slightly involved kind of statements, right? So let's say you want to write a program that displays the following pattern. So this is an example where we can use loop inside loops, right? So you want to display this pattern where we have this number 1, 2, 3, 4, 5. Then in the second line 2, 4, 6, 8, 10, and then. So what is happening? That there is one way you are printing this, right? So this is one loop is required here, that is to print this numbers in that sequence. So at one time you will get this is going to be the output. The next time this is going to be the output. Third time this is going to be the output, and so forth. So you've got a loop here, which is straightforward, just like we have seen the example of table, right? Printing the table of 5 or those kind of things. And there can be another loop which will allow to print within a loop, right? So this loop, I mean, there can be like here there are 5 number, but we can go up to 10 number, 15 number, 100 numbers in this direction as well. So printing of all those elements in this line, again, there is a loop within the loop, right? So we have the outer loop, which will go one by one row at a time. But within that, we have a loop which will go through the column. So we have got a row loop, which will go through rows one at a time. And then we have inside loop, which will be nothing but for that row, we have a loop which will print all those values along these columns. Right? So you see how we can make use of this loop within loop, right? So this is an example. This is the example, let's say for I in range 1 to 9. So I'm going to print from like these lines from 1 to 8. So because 9 is going to be terminated, so there's like 8 rows, right? And within that, I can have this another loop. So you can see this indentation. Now this is the body of this for loop, right? And you know that this is going inside, right? So this is the body of the for loop, and within that body, I'm writing another for loop. So this may have its own body, right? So the like loop within loop, nested loop. So what I'm doing here for I in range 1 to 9, which is like it will go from I equal to 1, 2, 3, 4, 5, 6 up to 8, right? And then we have this j in range. So I have another loop variable for this loop. So I is to be used for one loop, this outer loop. J is I'm using for the inner loop. And what I'm printing here, you see, and it is going up to 1 to 6. I mean, that means five times, right? So this print statement is going to get executed 5 times within this loop, within the inner loop. And what it is printing, I into j. So initially it is 1, and this is 1. So 1 into 1 is 1. So we are going to print 1. Then 1 into 2, then 1 into 3, then 1 into 4, then 1 into 5. And you see in this print statement, I am using this blank character as a separator. So it is going to print in the same line, right? So if you can recall, what we want to print is like 1 followed by 2 followed by 3. So this is like I equal to 1, then j equal to, j will take 1, then j will take 2, j will take 3, j will take 4, j will take 5. 6 it will not take because 6 that is terminated. So 1 into 1, that is 1. Then 1, I remain the same within that loop, but j is changed to 2. So 1 into 2 is 2. 1 into 3 is 3. 1 into 4 is 4. And 1 into 5 is 5. So this got printed. So you see within that inner loop for I equal to 1, we have gone through like all those. Right. So you can see that this print statement, and I'm allowing this print statement to print in one single line, right? And then followed by there is a print statement which is not taking anything. So why I'm putting this print statement to, which is a new line statement, right? It will move this cursor, right, which is printed 1, then followed by 2, 3, 4, 5, and then it will continue to print if I don't put this. So next time it will print next set of numbers here, and then next set number of after in the same line. But what I want is like it should move to next line, and that's why this print statement is there. Empty print statement, just like. I mean, it can be done in a different way also, but then yeah, the idea here is we want to print this arrangement of numbers, right? So we know that now next time the I is going to be 2, right? And then again the inner loop will go execute. So all that inner loop will execute, then the outer loop will get the next iteration. For next iteration, again that or inner loop will get execute, and then the outer loop will take the next iteration. So because it is loop within loop. So for one value of one iteration of outer loop, all possible iterations, whichever like possible, they will be getting executed for the inner loop, and then it will move to this. So what you need to remove this person who is creating a problem here. This always we have this world full of those idiots.
Okay, sir.
And this is another pattern. You want to, let's say, output, and it will be interesting you to experiment with this code. This code is given to you. So in the first line, it is printing only 1. So since this range, I mean, you see that every step you are printing different set of numbers, right? They're not fixed set of numbers. So you need to have this part. It will start with some number, but then this is variable number, right? So this range will give different set of numbers. And therefore, you need to design this range function in such a way so that it can return those numbers. I mean, the first time it will return only 1 number. Second time it will return 2 numbers so that the inner loop is going 2 times. Next time it should return 3 numbers and so on and so forth. So that is where you need to put your brain to figure out that how to design this outer loop. So since it outer loop is, we know that it's going to 6 times. So sorry, 5 times. So it will from 1 to 6. 6 is being the terminated one. So it will go from I from 1 to 5. And J is to go from some, you know that, so it is starting with the I, right? Every time, because for first line, it is starting with 1, second line is starting with 2, so 3, so it's starting with the I directly, this is straightforward. And then it is going to that many number of times. So you see, if we use this 2 into I. Now this expression from where it has come, this is the like a logic that you have to bring in. You have to like figure out, you have to think yourself that what you have to put so that this kind of output can be generated. So using this combination of for loops, like nested loops, you can print much more complex kind of expressions and patterns also. And there are examples or questions on that, how we can output this particular pattern. Let's say we have got 1 star here, then 2 star in the next line, then 3 star in the next line, and then this. Just think about it. I mean, how you're going to print this by your program, how you're going to generate this. So all possible different kind of pattern that you can come up with the different characters, like 1 or multiple characters. And you can just think of like, can they be generated programmatically? If there is some kind of pattern, obviously they can be generated. But if it is very random, I mean, just go through it and figure out that why it is not possible to write to generate some pattern in a programmatic way. And for some, it is quite possible. Yes, so there you will learn about more about like what is it meant by writing programs. So this is like a quiz for all of you, right? For I, and then this is like nested loop. So for I in range of 1 to 4, and for J in range I to cross I, right? So I think code is familiar, which you have already seen, and you have to print J. And end by dot. So what is going to be the output? Okay, since an interesting construct which we can use further inside a loop is break statement. Break and continue. There are 2 statements. One is called break, which we will be writing as BREAK, and then there another one is continue. Right. So we can make use of these 2 statements inside those loops, whether they are for loops or whether they can be while loops, we can make use of this break or continue. Now, why on earth somebody will use this break statement inside the loop, right? So this break is used for exiting a loop forcefully. So let's say if you are using for loop, which is supposed to run 100 times, but at some point of time, you are also checking some condition that if this satisfied, if you got money in your pocket, okay, just leave it, rest, I don't care. So you want to break that that execution, right? So you don't want to continue further. So you want to break. So that break statement is used for breaking a loop which otherwise going nicely. At some point of time, you might be looking for some situation, some condition to satisfy, and it got done. So you don't find any point continuing further. So you may use a break statement. So when you use break, it will break out of the smallest enclosing for or while loop. So as I said, it can be used inside a for loop or a while loop. And when you use this, depending upon which loop you have put in that body of that loop, that particular loop is going to get terminated. So if we have like loop within loop, obviously it will be terminated. That loop will be terminated with which is using this break statement. Right. So there is some program also like to explain this, how we can use this. Like let's say if you want to sum, let's say numbers and find some of the numbers, and anytime if there is a negative number, then you terminate. So what you want is like to sum positive numbers only, and as soon as you get a negative number, and maximum number to be summed is like 100. So outer loop, this loop that you are using is only one loop. For I in range of 100, you are taking input. So you, in principle, you are looking for 100 inputs, and you want to, let's say, sum them or whatever, you perform some operation. But as soon as you get a negative number, and the program suggests that you should break, I mean, then there is no need. So as soon as there is a negative number, then you don't have to sum them further, right? So you don't have to go around the loop anymore. So you break, and else you will, what you're going to do, you're going to sum that value. So this break statement here, right, what it is going to do, it is going to break this loop, this for loop at the point where the value is less than 0. So using this if statement, you are making a break, which is a conditional break.